SPLat is the only programmable controller product in the world that has been designed from the ground up as an embeddable controller component for original equipment manufacturers. SPLat provides a consistent set of control solutions for quantities from one-off prototyping all the way up to thousands per year. Hello, I'm David Gibson. I'm the Managing Director of SPLat Controls and co-developer of the SPLat concept. This presentation is designed to give you a general overview of what makes SPLat controllers so unique and how they fit into the OEM marketplace. To kick off, I will describe a breakdown of the OEM controller market as it existed before the advent of SPLat. I will then show you how SPLat is changing the OEM controller market and why SPLat is a better fit for the broad middle ground of the OEM market than any of the traditional solutions. Finally, I will explain why SPLat is uniquely able to provide OEMs with extremely cost-effective control solutions across a huge range of annual quantities. SPLat is a board-level product. That means we supply SPLat controllers as unpackaged printed circuit assemblies, ready to mount into an OEM user's own product. We offer SPLat controllers as a range of standard off-the-shelf products. These are all designed to provide a lot of useful, real-world functionality. Our standard product range includes general-purpose models, as well as ones that are targeted at specific application areas. For example, one of our products is optimized for water pumping controls, and another is aimed at industrial washing and cleaning equipment. What makes SPLat really unique, though, is that an OEM user can start off with one of our standard controller products, and as his sales volume increases, he can migrate to a custom SPLat controller that is a perfect fit to his specific needs. There are several stops along the way from standard SPLat to custom SPLat, so the transition is smooth and manageable, with little or no need for relearning, reprogramming, or other re-engineering. I am now going to give you a brief breakdown of the OEM controller market, separated into three broad categories of product offerings. I will then show how SPLat introduces something quite new into the mix, providing a unique set of attributes that makes it a better fit to the needs of more OEMs than any other product category. Many OEMs use traditional PLCs for their controls. PLCs have their roots in the industrial automation market and are comfortable for electrical and automation contractors. For some OEMs, PLCs work well, and the newer, very low-end programmable relay class of products appear to be very cheap. However, as many SPLat converts can attest to, the cost can quickly blow out if an application needs features that are not part of the base controller. In the PLC marketplace, specific function add-on modules can be extremely expensive, assuming you can even find one that fits what you need. While PLCs have their roots in industrial automation and the electrical industry, single-board computers are rooted in the microprocessor and computer industries. Some single-board computers are literally Pentium-class PCs on a board. However, while a single-board computer can be a computational powerhouse, it usually lacks the circuitry necessary to interface it to the physical world of sensors and actuators. That means the OEM must buy and connect additional boards with output relays, digital inputs, analog circuitry, etc. A full custom controller is a controller that has been specifically designed from the ground up for a particular piece of OEM equipment. In white goods quantities, a full custom design is the only solution. However, many lower volume products contain a full custom controller. This usually happens when it is impractical or ridiculously expensive to achieve the required functionality any other way. The development costs for a full custom controller can be high. Figures in the $100,000 range are common. Also, there are high risks associated with developing a custom controller. Development lead times can range from 12 months to never, and the OEM will usually be dependent on the original design company for any program changes. SPLat is a unique approach to programmable controls that occupies the middle ground between these various other technologies. To a large extent, SPLat fits in exactly where none of the others is a particularly good fit. We make SPLat controllers with a lot of onboard functionality, like operator interfaces and temperature measurement capability. And we make it easy to obtain add-on functionality. That means that some of the issues that in the past have forced OEMs into full custom controllers are addressed by off-the-shelf SPLats. However, SPLat is much more than just a range of highly functional off-the-shelf controllers. SPLat is a system that covers everything from standard products that are ready to use out of the box, all the way up to a set of processes for defining and designing customized SPLat controllers quickly, inexpensively, and with zero risk factor. With SPLat, It is perfectly possible for an OEM to start developing a product using standard SPLat for early prototypes. Then, as the product evolves, he can move up through various semi-custom SPLat solutions for early production. Finally, when the big numbers start happening, he can move to a full custom SPLat. In this section, I will outline for you some of the possible stages in the life cycle of a product that uses an embedded electronic control system. I will assume a hypothetical product that starts life as a proof of concept design, maybe in the OEM to B's garage. It is then developed into a production item and successfully brought to market. Finally, it evolves into a high-volume product with sales of several thousand per year. Normally, the control system will go through several design iterations along with the product itself. Early iterations are concerned with getting the product to perform properly and to tailor it to the needs and wants of the market. Later iterations are concerned with tuning up cost and performance parameters, and perhaps hiving off derivative products for alternative markets, such as high-end and low-end variants. On the next few slides, we'll look at some of the possible paths the evolution of the control system might follow. If the OEM is most comfortable with PLCs, the control system may well start out by using a PLC product. It is very likely, though, that the developers will have to add extra bits onto the PLC. If they are lucky, they may get away with standard modules like thermocouple or strain gauge amplifiers. If they have more unusual needs, they may not be able to find anything off the shelf to do the job. For example, we recently designed a custom interface to a particular brand of proportional hydraulic valve. You simply cannot buy such a circuit as a PLC add-on. As production volumes increase, the PLC approach becomes clumsy and uneconomical, and the OEM who doesn't know about SPLat will be forced into a custom design. An OEM who persists with regular PLCs into high-volume production will eventually become vulnerable to any competitor who uses custom controls, or a SPLat. A single-board computer would be the initial control system of choice for someone with a computing or electronics background. Just as with PLCs, the problem will arise of how to implement special functions. There are various approaches possible, but they all require electronic skills, a large budget, or both. Very often the developers will design custom I/O expansion boards to go with the single-board computer. From there, the move to a full custom controller is all but inevitable. Whenever the control system is converted from one technology to another, it pretty much amounts to a total redesign. In particular, the programming must be redone. The only thing carried over is the end product related know-how, i.e. the specification. Imagine therefore the nightmare in this scenario, which is all too common. Because the OEM is unaware of SPLat, he basically cannot find a control system that works well for him. Let's now see how SPLat changes this picture. SPLat offers you a range of solutions, starting with our standard off-the-shelf products. These include several base controllers and a number of special function add-ons. If our standard catalog doesn't contain the function you need, we can make you a custom add-on. Because the add-ons are usually quite simple and relatively easy for us to design, they can be affordable in batches as low as 20. Beyond a standard controller with a standard add-on, or a custom add-on, you can move up to a custom SPLat controller, with everything integrated onto one board. The typical threshold for a custom SPLat is a few hundred per year. The result of this is that it is now perfectly possible for an OEM to start out with a standard SPLat bought as a one-off developer's kit, and 1 or 2 or 3 years later be in volume production of his product using a custom SPLat that is totally tailored to his needs. Now, here's the kicker. During that whole journey from one-off to thousands per year, the programming remains the same. The same language, the same software tools, possibly even the same code, and most definitely the same investment in learning. There are no paradigm shifts, no sudden transitions, and no risky handovers to outsiders. Just one smooth, natural progression with the right SPLat control solution providing the best possible cost and performance at every stage. In the last part of this presentation, I'm going to outline for you the relative costs of the different control technologies and point out the factors affecting those costs. I will be presenting a set of graphs that compare the unit cost of each technology versus quantity, in the quantity range from one-off to 10,000 per annum. The trends I'm going to present reflect observations made across a large number of customers and projects in over 30 years of being in the embedded controls business. Let's start with traditional PLCs. The cost versus quantity curve for PLCs is relatively flat. PLCs are not designed for volume users, and PLC-based solutions often need special function add-ons. These can be expensive in the industrial automation market. Then there is the cost of actually fitting the PLC into the product. This can be a virtually irreducible cost where there are multiple modules to be mounted. What's more, PLCs offer few opportunities to simplify the wiring to make it suitable for low-skill labour. These factors prevent PLCs from achieving major economies of scale. Next up are single-board computers. I've assigned them a higher cost at very low volumes because of the more difficult programming. Single-board computers have more potential than PLCs for quantity discounts because they are much simpler to produce. Beyond that, a lot will depend on any add-on boards needed for real-world interfacing. The graph for single-board computers is prevented from dropping sharply with volume for similar reasons to PLCs, namely that the installation remains labour-intensive and expensive. PLCs and single-board computers are simply not engineered for volume users. With full custom controllers, the low volume cost is high because of the very high non-recurring engineering costs. As the quantity goes up and the NRE is amortized, the unit cost comes down dramatically. This has to be offset though by the high risk of a full custom controller design. There are many stories of custom controller designs that have cost a fortune without producing results. There are simply too many cowboys in the low end of the market, and if you want a top design house, you will have to be prepared to pay a lot of money. Finally, we have SPLat. SPLat is the only solution that can cover the whole quantity range, and we have a track record of successfully applying SPLat at every level of the market. At the one-off and low volume level, SPLat is competitive because of the large amount of onboard functionality and the availability of low-cost special function add-ons. Also, programming is much simpler than for single-board computers and is usually simpler than for PLCs. In medium volumes, even as low as 20 per year, SPLat gives further benefits like low-cost custom add-ons for special functions. What's more, the fact that most SPLat boards have plug-in connections allows a further saving, with pre-made wiring looms for fast, error-free interconnection in final assembly. At hundreds or thousands per year, a custom SPLat is bound to cost less than any off-the-shelf products. Our non-recurring engineering costs can be as low as 10% of a full custom controller, making a custom SPLat a realistic solution down in the few hundreds range. I hope this brief introduction to SPLat has inspired you to see the benefits SPLat can offer you in your particular situation. I have shown how SPLat is a new and quite unique approach to embedded OEM controls. We have seen that there have traditionally been three solutions to providing electronic controls for OEM applications. SPLat gives a new choice, and one that is a better fit across a huge range of applications than the traditional technologies. SPLat provides continuity from one-off quantities up to thousands per year. And finally, SPLat is the most cost-effective solution across the whole quantity range. If you would like more information about SPLat, please don't hesitate to contact us or visit our website at splatco.com. Thank you for your attention.